Have you ever wondered how long it takes to build a mountain? Some mountains are so old that their birth can be dated back millions of years, but this one was formed just a few years ago. So keep watching to find out more about this unusual mountain. The Earth is constantly changing. Its surface is not permanent. Landscapes are reshaped by natural processes over time. Oceans may rise and fall, deserts can expand or shrink, valleys can be carved by rivers, and mountains can be uplifted. Sometimes these changes happen slowly over millions of years, but other times they occur surprisingly quickly, geologically speaking, of course. The relatively young age of some mountains never ceases to amaze scientists. For example, Mount Toba in Indonesia was formed just 74,000 years ago. Mauna Loa in Hawaii is even younger, having been created around 20,000 years ago. And there are many other similar examples. But these mountains are like toddlers compared to some other mountain ranges. The Appalachian Mountains, for instance, began forming 480 million years ago. They've had plenty of time to get old. However, even these ancient giants were once newly formed mountains. In 1965, scientists recorded the birth of an ephemeral mountain that only now is disappearing beneath the waves. It was born in the middle of the Atlantic Ocean during the Azores Islands volcanic eruption. This event lasted from January 1965 to November 1967. During those 2 years, magma chambers erupted with such force that the ocean floor rose up and became a new island. The event was unprecedented in terms of both its speed and scale. It was the first time a volcano had been observed from birth to adulthood. Scientists could witness how the island grew month by month and how it changed the surrounding landscape. So, where exactly did this ephemeral mountain appear? Now you might think it sprouted in the vastness of the ocean where no one would see it. But the emergence of this island was recorded on satellite images of the Earth. In fact, the island appeared near São Miguel Island, part of the Azores archipelago, which is part of Portugal. But unlike its neighbors, this island was short-lived. Now it's gone. Here's why. In August 1965, 6 months after the initial eruption, scientists noticed that the island had begun to shrink. Waves broke against the western cliffs, causing rocks to crumble and slide into the sea. Even though new land continued to emerge from the depths of the ocean, it was eroded away faster than it was formed. By December, the island was barely visible above the waves. The erosion process was accelerated by heavy rainfall and strong winds. In November 1967, the island ceased to exist altogether. The final eruption was recorded on December 11th, but it didn't bring about the formation of a new landmass. Instead, lava flowed directly into the sea, leaving behind only a new underwater mountain. The island that had been growing since 1965 disappeared under the waves, along with its highest peak. But in the place of the peak, a new one arose. Scientists used various techniques to study the birth of this island. At first, they used aerial photography. Photographs were taken from planes flying at an altitude of 3,006 meters. These images helped track the growth of the island every couple of weeks. But when the island got bigger, planes couldn't fly so low. So then scientists started using ships equipped with special cameras that captured images from a lower altitude. When the island emerged from the water, scientists could finally observe it from the air and on the ground. They studied not only the shape of the island, but also its chemical composition and the gases emitted by the volcano. This mountain was named Barreto after the local whaling captain who was the first to spot the emerging island. Barreto became the youngest island in the Azores archipelago, and for the first time in history, scientists witnessed the birth of an island that later became part of a mountain range. Prior to this, scientists could only theorize about how such geological wonders came to be. They could study the layers of solidified lava, examine the types of rocks and minerals, and trace the paths of tectonic plates. But all that gave them only a partial picture. The emergence of Barreto gave scientists a unique opportunity to see the whole process with their own eyes and collect valuable data. Here's what they found. First, the submarine volcano grew rapidly. In the first 2 months alone, its height increased by 243 meters. A year later, its height reached 654 meters. That's almost 150 meters higher than Mount Fuji, the iconic Japanese mountain. The most active period of growth was between January and April 1965, when the island gained an average of 18 meters per day. In total, the mountain covered an area of 2.5 square kilometers, and its slopes extended 15 kilometers from northwest to southeast. However, the mountain was unstable. Frequent earthquakes caused landslides and avalanches of volcanic material. Scientists recorded up to 300 tremors a day. Most of them were minor, but some were quite powerful, reaching a magnitude of 4 on the Richter scale. One landslide alone displaced about 60 million cubic meters of rock, and that's just one landslide. The rocks slid down the southeastern slope of the island and formed a debris flow that rushed into the sea at a speed of up to 80 kilometers per hour. The flow traveled more than 12 kilometers along the ocean floor before finally coming to rest. Debris flows repeatedly changed the shape of the island, eroding it and transporting rocks from the upper part of the mountain to the lower part. Despite the instability, the mountain continued to grow until November 1967. During this time, hot lava flowed from vents located not only at the summit, but also on the flanks of the mountain. Thanks to satellites, scientists could monitor changes not only in the size and shape of the island, but also in the surrounding ocean environment. For example, they were able to track changes in water temperature. It turned out that during the eruption, the water temperature near the island increased by several degrees. Hot springs contributed to the formation of steam clouds that were sometimes mistaken for smoke. The steam rose high above the island, sometimes even more than 9 kilometers, but it wasn't just water vapor. Volcanic gases escaping from vents contained carbon dioxide, sulfur dioxide, and hydrogen sulfide. Scientists discovered that most of the gas emissions came from the base of the mountain. The hot springs released significant amounts of heat into the ocean. Initially, the water temperature near the vents reached 130 degrees Celsius. Later, this figure dropped to 100 degrees. The warm currents spread throughout the ocean, increasing the temperature of the surrounding water. This phenomenon was especially evident in winter, when the sea surface temperature normally drops significantly. The hot springs also contributed to the formation of hydrothermal fields, areas of the ocean where the water temperature is higher than normal due to geothermal energy. Hydrothermal fields often teem with diverse and unique forms of life. However, this diversity was limited in this case. The waters near the island were too hot for most marine organisms. The number of species in the region decreased with increasing distance from the mountain. Only a few types of plankton and fish could withstand such high temperatures. In general, the impact of the mountain on the ocean was significant. As it grew, it changed the direction of ocean currents. Previously, the Canary Current flowed through the gap between Snow Miguel Island and the emerging island. However, as the mountain grew, it disrupted these currents. The mountain acted as a barrier, altering the movement of water masses and affecting the exchange of gases between the ocean and the atmosphere. The birth of the island brought not only challenges, but also opportunities. Plants quickly colonized the barren slopes, taking advantage of the fertile volcanic soil. Seeds were carried by the wind or by birds that nested on the island. Within just 2 years, the mountain was covered with tenacious vegetation. Animals arrived later, mainly birds and bats. They were attracted by the abundance of insects that appeared along with the plants. By the end of 1967, when the mountain stopped growing, it had become a full-fledged ecosystem, albeit one that was still isolated. The species that settled on the island were well adapted to harsh conditions. The climate was dry and windy, and there were frequent earthquakes. But despite these challenges, life found a way to thrive on the young mountain. But what happened to the mountain next? After all, we know that now it's underwater. The fact is that the eastern and southern slopes of the mountain were subjected to severe erosion due to heavy rainfall and strong winds. This led to the formation of deep ravines and gullies. The loose structure of the volcanic ash contributed to the rapid development of this process. Moreover, in 1998, Hurricane Lloyd played a significant role in the erosion of the mountain. Its strong winds and torrential rains washed away large areas of soil, accelerating the destruction of the mountain. Over time, the western and northern slopes also suffered from erosion. The mountain lost its original shape, becoming lower and wider. Currently, it continues to erode, although much more slowly than before. It's difficult to say exactly when the mountain will completely disappear. However, judging by the rate of its erosion, we can estimate that it has no more than 60,000 years left. But perhaps by that time, nature will have already created something new on its ruins. Or maybe it'll just be another mountain range. Do you know any other amazing places on our planet? Share your thoughts in the comments. And don't forget to subscribe to the channel. See you soon!